In the previous two videos, we introduced binary number and the hexadecimal number. So now, according to the size for the memory location, remember before in C++, we told you one integer number, the size will occupy 4 bytes. Then double number will occupy by 8 bytes. So those, what the meaning? We only discuss about integer value here. So what does that mean if I have the integer value occupy 4 bytes? So that's why how much the value can store in that location is really according to your storage size. In assembly language, we're using different units to represent how many bytes we have. If you only have 1 byte, we call byte. That's 8 bit. 2 byte we call word. 4 byte we call double word. So then 8 byte we call quarter word. So in assembly language, they not really have the integer, double, or character data type. In assembly language, we only care is about the storage size. You just reserve the location, how many bytes you want to have. So you have 1 byte or word, 2 bytes. Then you have double word, 4 bytes, and a quarter word. So how you will decide you want to reserve a location? Should I do byte, word, or double word, or quarter word? Actually, it's according to what the value you want to store. If you want to using only 1 byte, you have 8 bit, right? So here, your data type for 1 byte, actually they start from 00000 to all the 11111. So that's why the value range is from 0 to 255. Or you can say that's 2 to the 8th power minus 1. So this kind of value, we just say integer storage size. So if they don't specify, integer storage size actually mean unsigned integer. Because when I save the value, I don't have a sign. So you need to be careful. It's not we don't have positive. So here actually we don't really have positive and negative. So those when we say the unsigned byte just mean all the value, all the bits are using the value to calculate, are using all the bits to calculate the byte. We're using all the bits to calculate the value. So all the bits, they have the value to calculate for. It's no bit represent for the sign. So that's what we call the unsigned type. If you are unsigned type data, 1 byte, the value is between 0 to 255. 2 byte between 0 to 2 to the 16th power minus 1. So you can see the value is very big. So that's why usually 4 bytes, we don't write that many. We just do because you have 32 bits. So that's 2 to the 32 power minus 1. So definitely you can know if that's 8 byte, then you have 16 bit. The value will be 0 to 2 to the 64 minus 1. So now, did you remember before in C++, we do have the unsigned int, unsigned double, right? So when you do the unsigned, you define unsigned, that means all the bits we're using toward to calculate the value is no sign available. So that's the integer storage. But we do have sign value we want to store, right? Right, so if you know your integer doesn't need a sign, then you do the unsigned. But your sign is really matter. We call that the sign integer. So what is the sign integer? So that's why the first thing we need to talk about. What are sign integer? So the sign integer actually is we're using the 1 bit to represent their sign. So before we told you, right, we say the most left is most significant bit. Most right is least significant bit. But if we want to using the value to represent sign value, actually the highest bit is always with the most significant bit. The highest bit on the left, we will reserve for the sign. If that bit is 0, mean that's positive. If that bit is 1, it's negative. So that's make the sign bit. So the sign integer, actually we're using the highest bit to indicate the sign. So that's why this value is not whole word to the total value. So that's why here you will see, after you have the sign integer, you understand, right? Sign integer, if I want to specify the byte for the sign byte, since I reserve the most significant bits as sign, so that's why their range will become -128 to the +128. Over here is the range. So you can see they're losing 1 bit to using represent the sign. So for positive, you start from 2 to the 7th power minus 1. Then negative, you can do until -128. So the same thing, that's the 2 byte. So that's the 4 byte. So that's the 8 byte. So that's for the sign integer. So then why we talk about sign integer? The reason is, did you notice earlier when I talked about binary addition, I didn't talk about binary subtraction, right? So actually we didn't talk about the binary subtraction. That's because for the computer world, they don't do subtraction. Instead, you have a number. Like for example, I do 54 minus 28. Yeah, in computer world, they don't do minus. Instead, they consider it's 54. We only do the addition. But I add what? Right, I add -28. So computer world actually we only do addition. So addition actually is to represent you add a negative number become the subtraction. So whenever you want to do a subtraction, actually we don't do subtraction. We do the addition with a negative number. I believe now you have a little confused now, right? What does that mean? I don't do the subtraction. Let me show you the reason why we don't do the subtraction. So let me show you 2 subtraction example like this. If I have a number, binary number 1100 minus 0011, can you do the subtraction? This one not too bad, you can do the subtraction. So then here you can see 0 minus 1. Do you have enough to minus? No, you don't have, right? So that's why you need to borrow. When you borrow from 0 on the previous digit, no, you don't have 0. So that's why they need to continue to do the big one here to borrow from this one. So this one, after you borrow, they become what? Right, actually they become 2. They become 2 for here. Yeah, because this one you borrow, they will become to the next digit on the right. This one will become 2. So this 2, right, so I can borrow 1 to you. So then when this 2 borrow 1 to the next one, they will become 2 as well. So that's why you see here the 2. So that's 2 become here, right? So 2 minus 1 is 1. So then we can see 1 here. So the 2 after you borrow become 1. 1 minus 1 is 0. So this one being borrowed, so this gone. So that's why you still have this 1. So your answer is 1001. Okay, this way you do the subtraction for binary number is okay. Because 11001100 is equal to the decimal 12. When they try to minus 0011, you try to minus the decimal 3. So 12 minus 3 is 9. Yeah, we can do that. However, let me show you the other one. Okay, if you have another number is 101, you want to minus 1001. You see, let's see how you can do the subtraction. Okay, you're going to see here. 1 minus 1 is 0. 0 minus 0 is 0. 1 minus 0 is 1. This 3 is okay, right? But here, when we have a 0 minus 1, okay, where will you borrow? Where will you borrow? You have no way to borrow, right? Because earlier our 1, okay, so we see here, 1001 is 8. 8 plus 1 is 9. Okay, so 101 is 4 plus 1 is 5. When you have two numbers subtract each other, if the first number is smaller than the second number, in the binary number, we don't know how to borrow. And also, actually, in the real world, you don't know how to do 5 minus 9, right? Okay, in the real world, how you do 5 minus 9? You cannot do 5 minus 9 because 5 really cannot minus 9. So what we do is we know 5 is smaller than 9. Actually, we do 9 minus 4, or 9 minus 5 become 4. Then we add that negative number, negative sign. So on the other hand, right, so in the real world, even we cannot really do the smaller positive number to minus smaller positive number to minus a bigger positive number. We're not really direct to do that. So on the other hand, right, that's earlier I say, in the binary system, when you have the number do the subtraction, actually they don't do the subtraction. They always do is they using the subtraction become addition, but they make this number become negative. So the most important thing is we want to show you how to represent negative 28 in the binary system. Because so far, remember earlier, all the number we talk about from decimal convert to binary, we only talk about positive number. So that's why now, for example, negative 28, how you will represent negative 28. So here, instead of to show you negative 28, I want to show you negative 1. So you can see here is a binary number, right? So definitely you know 0.000001 equal to what? Right, decimal number equal to 1. Okay, so let me tell you one thing. If I want to represent negative 1, here is negative 1. Then you will say, what? 1, 1, 1, 1, 1, 1, 1, 1. It's negative 1. How come? Okay, let me explain to you why. So 1 and the 1, 1, 1, 1, 1, 1, 1, 1. This one is negative 1. Why? I just proved to you one thing. Okay, can you tell me 1 plus negative 1 equal to what? Yeah, 1 plus negative 1 equal to 0, right? Good. So when we say negative number, actually in the real world, it's no negative number. Yeah, negative sign actually just represents what is the direction. Or mean you see you are in debt. You price positive 5, that means you have $5. But if negative 5, that means you have your $5, but you owe by someone else. So that's why whenever we talk about the positive number and the negative number actually mean the complementary for the positive number. Positive number 5 mean you have 5 units from the origin 0 on the right. But negative number mean you have 5 units from the origin to the left. They are complementary to each other. Any positive number plus their negative, the same value number, will equal to what? Equal to 0, right? So then, can you see here? 1 plus 1, 1, 1, 1, 1 equal to what? Can you do the addition? Right, you can do the addition, right? So 1. 1 plus 1 is 0. You carry over 1 becomes 0. Carry over 1, carry over 1, carry over 1. So that's why here, after you carry over 1, right, that's all 0. Okay, so that's we show you. When you have negative number, actually we call that the 2's complement. You want to find a negative number in the binary system, you need to find their 2's complement.